Hello, I'm Dr. Steve Warner, and today I'm going to talk about the Pythagorean theorem and the distance formula. Let's start with the Pythagorean theorem. This theorem says that if a right triangle has legs of length A and B and a hypotenuse of length C, then C squared is equal to A squared plus B squared. Note that the hypotenuse of the right triangle is always opposite the right angle. Let's look at a simple example. Given right triangle, triangle PQR below, what is the length of segment PR? Okay, well, we're going to use the Pythagorean theorem. Let's call this side C, and we have C squared is equal to 3 squared plus 5 squared, which is 9 plus 25, or 34. So C is the square root of 34, which is choice D. One technical thing that's worth pointing out is that normally when you have the equation C squared equals 34, you would solve this using the square root property, which gives two solutions, plus or minus the square root of 34. But in this case, we're dealing with the length of the side of a triangle, and lengths can't be negative, so we always reject the negative solution. So when using the Pythagorean theorem or computing distances, we can always forget about that extra negative solution. Let's try another example. Given right triangle PQR below, what is the length of segment PQ? Okay, be careful. This time we're given the hypotenuse and not given one of the legs of the triangle. So let's call this side length A. And by the Pythagorean theorem, we have A squared plus 12 squared equals 13 squared, or A squared plus 144 is equal to 169. Subtracting 144 from each side of this equation, we get A squared is equal to 25, so that A is the square root of 25, which is 5, and that's choice C. Once again, I'd just like to mention that we only take the positive solution here because we're looking at the length of the side of a triangle. Also, there's a quicker way to do this if you happen to recognize the Pythagorean triple 5, 12, 13. Some of the most common Pythagorean triples are these: 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. If you happen to know these Pythagorean triples, it could make some questions involving right triangles much quicker and easier than going through the whole process of applying the Pythagorean theorem. If you don't remember these triples, it's not too big a deal. Then you just have to use the Pythagorean theorem. It's also worth mentioning that any multiple of a Pythagorean triple is also a Pythagorean triple. For example, if we look at the Pythagorean triple 3, 4, 5, we can multiply each of those numbers by 2 to generate a new Pythagorean triple. 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So 6, 8, 10 is also a Pythagorean triple. We could do this with any Pythagorean triple and any number that we choose to multiply all three of those numbers by simultaneously. Let's try another example. What is the distance between the points -2, 7 and 3, -2? Okay, let's use the Pythagorean theorem to solve this problem. Let me start by drawing a picture and plotting these 2 points. So let's say the point -2, 7 is about there, and the point 3, -2 is about here. and we want to find this distance. we could turn this picture into a right triangle like this. And it might be worth noting that this is the point, -2, comma -2. Now, this distance here is 9. We could do it by just observing that we could go up 7 and down 2, or more formally, we could subtract 7 minus -2 to get 9. And this horizontal distance here is 5. Again, we could do it the same way. We could either count 3 to the right and 2 to the left, or we could formally take 3 minus -2 to get 5. And now we could get the distance we're looking for by applying the Pythagorean theorem. So c squared is 9 squared plus 5 squared, which is 81 plus 25, which is equal to 106. So c is the square root of 106, choice B. Some of you may be wondering why I didn't use the distance formula to solve this problem. Well, that is actually another option. So let's review the distance formula. The distance between the points st and uv is d equals the square root of u minus s squared plus v minus t squared. So let's try this same example again using the distance formula. Well, d is the square root of 3 minus -2 squared. I'm subtracting the x coordinates and squaring, plus, and then I subtract the y coordinates and square. Okay, so that's equal to the square root of 3 plus 2 squared plus 7 plus 2 squared, which is the square root of 5 squared plus 9 squared, which is the square root of 25 plus 81, and that's the square root of 106. Once again, that is choice B. Let's do one more example. In the xy coordinate plane, what is the radius of the circle having the points 2, -4 and -4, 4 as endpoints of a diameter? Let's draw a quick picture. The point 2, -4 is about here, and the point -4, 4 is about here. And this is the diameter of this circle. Let's start by computing the distance between those 2 points to get the diameter of the circle. We'll use the distance formula. So we have d equals the square root of -4 minus 2 squared. We subtract the x coordinates, plus 4 minus -4 squared, subtracting the y coordinates. That's the square root of 36 plus 64, which is the square root of 100, or 10. So the diameter of the circle is 10, and the radius is half the diameter, so the answer is 5, choice A.